This is concept 4, number 10, part A. This is the cart of the roller coaster, and you have force gravity going down. You don't want to add any force normal or any additional forces going down because you want the minimum speed of the car. If you added any more force, it would increase the centripetal force, which would increase the velocity. So your force gravity is going to be 10,000 newtons because the mass is 1,000 kilograms. And this is equal to the mass times the velocity squared all over the radius, which is 5 meters. Then your velocity comes out to be 7.07 meters per second. Moving on to part B, you need to find the initial height that the car was. You can do that by finding gravitational energy, which is mass times gravity times height. But first you're going to find the total energy. So you want to find the total energy when it was at the top of the loop from the previous problem. You know that the kinetic energy at that point was 1/2 times the mass times the velocity squared, so 7.07 meters per second, that quantity squared, and that equals 25,000 joules. Then you're going to want to find the gravitational energy at that point. And gravitational energy, again, is just the mass times the gravity, which is 10 newtons per kilograms, times the height, which was 14 meters, and that equals 140,000 joules. So the total energy would be these two combined, and that is equal to 165,000 joules. Then you can use that because energy is conserved, so this energy must be the same as the total energy at the initial position. Plug that back into the gravitational energy formula. So mass times gravity times the height. The height comes out to be 16.5 meters. Now we're going to go start part C. It asks how far the car would compress the emergency safety spring, and here all of the total energy in the system would equal elastic energy after it's been totally compressed. So your 165,000 joules would be equal to 1/2 the spring constant K times the change in X squared. You know that K is equal to 1.4 times 10 to the 4th Newton divided by meters. We're looking for change in X squared. When you solve that all out, the change of X comes out to be 4.85 meters. Okay, for part D, we're going to use Hooke's law, which is force is equal to spring constant times the change in X, to find out the net force. And the spring constant is 1.4 times 10 to the 4th Newton over meters. And your change in X, which is from before, is negative 4.85 meters. So your force comes out to be negative 67970 newtons. Go ahead and plug that in to Newton's second law, which is force equals mass times acceleration. Your mass is 1,000 kilograms, so your acceleration comes out to be 67.97 meters per second squared, and that's negative.